Hello. Welcome to Horat 2022. Thank you for your contribution or Congress. There are 7 presentations in this session. The maximum duration for each presentation is 50 minutes. All presentations are recorded. It will be broadcast on YouTube after the Congress. First presentation, Dear Abdullah Abdu Ibrahim. Paper title, Float Forecasting Using Neural Network. Dear Ibrahim. Okay, he's not connected. Dear Tabrizi. Aryan Roshani Tabrizi.
Yes, I'm here. May I start?
You can start.
Okay, let me share my screen. Sorry. So can you see my screen?
Yeah.
Okay, let me start. Hello, my name is Aryan Roshani Tabrizi. I'm from East Seminary University, Department of Electrical and Electronic Engineering. My research topic is energy management system optimization for grid-connected microgrids in presence of energy storage. This is my table of contents. It starts with introduction, then I will go to microgrid components, then I will discuss about my literature review, problem formulation, optimization methods, methodology, case study and results, and at the end, I will discuss about the conclusions. As it is shown in figure 1, the world population is predicted to grow, and it leads to an increase in energy consumption that can be seen in figure 2. Because of the present expanding need for electrical energy, small-scale renewable energy sources are increasingly being integrated into modern electric systems. Renewable energy has seen significant technical development, allowing it to be produced at low cost. This advantage helps nations to increase their energy security by reducing fossil fuel imports, which allows them to keep their costs lower than normal and raise their standard of life without affecting the environment. The microgrid provides an effective approach for the complete utilization of renewable energy, thanks to advancements in distributed technology. A microgrid is a combination of distributed energy resources, such as renewable energy sources and energy storage systems, as well as load and other components that can be controlled locally and operate in a grid-connected or islanded modes. As it is clear in this figure, I have used PV solar generation, wind turbines, and also fossil fuel generation in presence of energy storage system in a grid-connected microgrid. And also my loads consist of domestic loads and also commercial loads. And these are some of the articles that have used similar optimization methods and also some similar components in their case studies, which were really helpful for me in this study. PV generation cost is calculated using produced power by panels considering the investment cost. And the solar radiation of a specific day is shown in figure 4 that can be seen here. And the next component is wind turbine energy production. Wind turbine power generation is a function of wind speed, and its cost function variable is the generated power by wind turbine. And the wind speed of a specific day is shown in figure 5. Although the main purpose of employing microgrids is to focus more on managing renewable energy sources, in some conditions, it is more reliable and economic to generate power using fossil fuel. In this study, the cost of releasing greenhouse emissions into the atmosphere is considered in addition to the fuel consumption cost of fossil fuel generation. Energy storage system. The concept of energy storage system is to operate as a load when there is excess energy and inject the stored energy into the system whenever it is needed. In this study, the charge and discharge decision-making policies are dependent on the result of economic dispatch calculations. The charge and discharge cost formula are mentioned here. Demand response program actually is also employed to make the system more reliable and economic. In the high demand time intervals, an incentive payment is considered for consumers who reduce their adjustable load. The amount of money that is paid to consumers is considered as the cost of applying the demand response program in the microgrid. And the other component is the main grid purchase. Depending on the amount and the cost of produced energy by distributed energy resources inside the microgrid, in some periods, purchasing power from the main grid leads the system to be economic and reliable. The cost of the main grid purchase is calculated considering the price of the energy per hour and abonnement cost. The summation of the total supplied power to the microgrid must be equal to the total load in all time series and also be economic as possible. Therefore, the cost function of energy storage system, demand response program, and all other suppliers should be considered to obtain the economic dispatch using optimization methods. Here you can see that the total produced power generation, the total generated power must be exactly same as the demanded load. And also, so the main constraint of this study when the energy storage is in charging mode is shown in this formula. As you can see here, we have a negative sign for PES, that is the symbol of power generated by or power used by energy storage system. Whenever it is negative, it means that the system is in charging mode and it acts as a load in our power system, in our microgrid. But whenever it is in discharging mode, you can see this positive sign here. So it means that the energy storage system is supplying power to the microgrid. So it acts as a generator in the system. In order to obtain the optimal economic dispatch of microgrid generation, while it is equal to demanded load in all time series, two different optimization algorithms using MATLAB software are employed. Genetic algorithm and multi-objective particle swarm optimization, or GAN MOPSO. In both of the algorithms, the generation cost function of all components of microgrid are considered and the energy storage state of charge is determined. After finding the optimum value of economic dispatch, the voltage level will be calculated using power flow analysis. If it is in permitted voltage range, the calculations will be ended. Otherwise, the algorithm will run again. And the flow chart of discussed program is shown in this figure. In this study, as I mentioned before, I have used two different optimization methods and I compared the results. The first one is genetic algorithm, or GA, that you can see the flow chart of a standard genetic algorithm in figure 11. And the other one is multi-objective particle swarm optimization, or MOPSO, that the pseudocode of the general MOPSO algorithm is shown in figure 12. And the IEEE 33 bus power system is considered as a case study, which is supplied by the main power grid in addition to the DER, or distributed energy resources inside the microgrid. Employing dual solving method for this problem allows to compare the difference in the results in obtained outputs. The most crucial economic dispatch and powerful optimization outputs of genetic algorithm and MOPSO are discussed in this research. And the first result is energy storage system. As it is clear in figure 14, the results of both methods show that in the low demand time intervals, mostly during the night, the produced power by energy storage system is negative, which means that it is in charging mode and behaves as a load in the microgrid. On the other hand, in peak hours, the stored energy will be released to supply microgrid's load. The comparison of two methods shows that using MOPSO leads the microgrid to rely on energy storage system more than using genetic algorithm. The voltage magnitude deviation is shown in these two figures, 15 and 16, for GA and MOPSO methods, and compared with the voltage level of before applying economic dispatch, the graph in blue. Although in MOPSO method, there is more fluctuations in voltage deviation, but in both methods, the voltage magnitude remains in the standard range. The next result is the output of energy management. Energy management program has applied using both methods in order to supply energy to microgrids load in 24 hours time series in an economic approach. It is obvious that the results of GA and MOPSO methods that are shown in figures differ slightly. The comparison between demanded load and the result of energy management in both methods declares that the demand response program has reduced the microgrid's load in some time intervals. This reduction of load provides a situation in microgrid to have excess energy production by wind turbine and macro turbine, which is stored in energy storage system to be used in peak load periods between 7 a.m. to 8 p.m. that there is enough solar radiation. Therefore, most of the energy consumption has supplied by PV panels. Diesel generator production and utility purchase has a small share in some short time intervals, which there is not enough solar radiation or wind speed. And this figure presents an economical comparison of genetic algorithm and MOPSO methods. As it is clear, both of the methods provide almost same economical results in most of time intervals, and it can be seen that in hours that there is sufficient solar radiation, the generation cost has been dropped up to 40%, which means that PV solar generation plays a major role in minimizing the generation cost. A closer look at figure 19 declares that MOPSO provides less generation cost in some time intervals. And conclusion. This research presents a comparison between two optimization methods, GA and MOPSO, for minimizing the generation cost of a grid-connected microgrid consists of PV solar panels, wind turbine, and fossil fuel generation, energy storage system, and employs demand response program, and the main grid purchase, considering voltage deviation before and after applying optimal management. The results show that the generation cost in MOPSO method is more economic and it employs energy storage system more than genetic algorithm method. PV solar generation takes lead in generation cost minimization. Voltage deviation outputs shows that in both algorithms, the voltage fluctuations are increased after applying management program, especially in MOPSO method, but still it is in the standard range. And thanks for your attention. If you have any question, I'm here.
Thank you for presentation. Is there any question about presentation? Okay, thanks again. Next presentation. Ali Jamal Al-Sadi.
Yes, Ali Jamil.
Okay, you can start.
Yes. You sure now? You're looking for the presentation?
Yeah.
Okay. We can Design and simulation of a smart parking system using image segmentation and deep learning. Introduction, because background, in addition to chaotic traffic and the traffic jam, there is an increasingly frequent problem of finding parking space. The question is where to park. Frequent problem of finding parking space. The question is where to park all these million vehicles. Going further, the project focuses on the problem of controlling vehicles within a smart parking lot, even being inside a provide or car park is not easy or quick to lock for an available space. This diagram, the cleaning for horizontal years and vertical cars and people. This diagram showed responsible what people need for the cars and how to increase the request for the card. Yeah, yes, the main reason I mentioned for the thesis, the movement of people from the countryside to the city. Problem, finding a parking space nowadays become an issue that is not to be neglected, is consumed time and energy. We have used computer vision techniques to infer that state of the parking lot given data collected from University of Witwatersrand and location South Africa, found in the year 1922. Proposed solution. In this work, a control system presented of affliction, the location of available parking space, the indication of available space closest to your location for the vehicle driver is made through a display at the entrance to the parking lot. How did we choose computer vision? There are two major approaches for the detection of empty parking spot. Sensor called peer inside and very parking spot, detecting the presence of a car. Alternatively, visual information typical to collect from peer inside security cameras could be used to determine if parking lot is empty or not. The first approach is quite expensive to realize, while the second approach could leverage existing simulation system and therefore be much more visible. Contribution. Our main contribution are concluded as follows. We propose a dataset of parking lot image. We implement a deep learning scheme to recognize empty and full parking lot. We simulate the car vision in a 3D view in MATLAB version 8090 copy A. We evaluate our model accuracy and compare to other work in the literature. System materials. Computer vision. Computer vision is field or artificial intelligence between AI that enables computer and system to derive meaningful information from digital image, video, and other visual input, and take action or make recommendation based on that information IF. And enables computer of think. Computer vision enable them to see, observe, and understand the picture, cleaning your observe and understand the camera between for computer vision and various between the anybody or a human or the car on another that body. Computer vision and machine learning. Computer vision training machine to perform this function, but it has to do it much less in time with cameras, data, and algorithm rather than ratings, optic nerves, and a visual cortex. Because a system trained to inspect products or watch production assist can analyze thousands of products of a process a minute. No tech unpredictable detect or issue. It can quickly surpass human capabilities. Computer vision work much the same as a human vision. Expect a human have a head start. A human set has advantage of lifetimes of context to train how to tell objects apart, how far away they are, whether they are moving, and whether there is something wrong in image. The picture, your explanation are for the same. By default, you chose or poke the place. Computer vision data. The data set is made of 782 images of parking lots. Those parking spots have been extracted from different parking lots of the internet. This data available online or free for research, and the URL for dataset is set both on paper and thesis. The dataset and mobile information and shows parking color and parking aggressical. Computer vision algorithm, CNN. Machine learning using algorithm model that enable on computer teach itself about in context is visual data. If enough data is fed through the model, the computer will look at the data and teach itself to tell one image for another algorithm, enable the machine to learn by itself rather than someone program it recognize an image. A CNN help machine learning or deep learning model look by parking image down into pixels that are given text or labels. It issue that the labels or perform convolutions are mathematical operation on two function to produce or third function and makes a prediction about what is seen. The neural network run convolution and check the accuracy of the predictions and series iterations unit the predictions start to come true. It then recognizing or seeing image in way similar to human. This you're cleaning for a convolutional layer on a 3 layer between the car or the body and 3 layer and arrive the full connect layer become finally out by exactly problem proposed method. CNN implementation, training and testing. Training the algorithm and train on 70 Hz data ratio with 4 epochs and 50 iterations. The algorithm learn only 2 labels, empty and full. At the final classification is a binary classifier because your language computer binary. Testing after the training affairs, the generated convolution neural network mode cameras along with 2 other fields. Label text contain the different label of a spot, vector or occupied, and the deploy protects, which the new network configuration used by the model. This field define the type of input allowed by the model and the protocol followed. to produce the output. This picture or the diagram, you're cleaning the testing and running for the CNN problems. The output of this list fully connected layer goes through a softmax layer, which converts the fully connected layer output into a set of classified probabilities on for each class. To improve the CNN performance, a loss function is used estimate the equality of the CNN answer its class score. We use the negative log hood as the loss function and CVM as final classify and softmax. The declining method and accuracy for the test and your result for this CVM method classify color model, your CVM, I meaning support vector machine. Support vector machine, you have 83.6% accuracy. KNN, your with color historical, you can and K nearest neighbors. This 94.0% accuracy, CNN and CVM using the algorithm and CNN convolution neural network, your accuracy 98.1%. The graphic you're cleaning, you chose another weather or the effect on the, what did you affect for the negative or positive for the negative for the color cloudy and sunny and rainy on all the weather, and this result conclusion we proposed an approach for parking space occupancy classification by way and convolutional neural network, which have an outcome dependent on a parking space occupancy. Additionally, we did a conversion to viral exciting non-deep machine learning method, and we run to proposed methodology and the data set a huge publicly accessible parking lot picture data set. We have discovered that applying convolutional neural network to the targeted issue help. The final thank you listening.
Thank you for presentation.
Thank you, Doctor. Thank you.
Is there any question? Thanks again. Next presentation. Dear Ahmet Albayati.
Hello, everybody. I am Ahmed Albayati. Today, we are going to present our recommendation system on Twitter data. We use recommendation system for marketing purposes by content-based filtering. First, the presentation content will be the project idea and our method, and what are the objectives and what are the importance of using the method. After that, we will briefly discuss the mechanism of the application and the data preparation and the algorithms or the used methods. Also, we will discuss the result and the conclusion. Firstly, the main concept of our method is to enhance online commerce and marketing. Since the recommendation system makes shopping very easy for customer and vendors, and it is used widely to many different sites, we are using it with Twitter data to provide a target list for vendor. Our project could be used as a useful tool for vendors to get a target list by Twitter users. The objectives could be increasing e-sales value, provide an easy way to reach targets, attracting people to e-commerce, also using tweets to build a machine learning system. So the importance of the method. For both of vendors and e-commerce, there are many useful points which we could reach by using our method. Simply, it will increase the average order value. The average order value will be increased and the number of items per order will be boosted. Also, it could help to sell items that have never been searched before by the users of the e-commerce site. How does the method works or the mechanism of the method? As the first step, and about the data set, we are fetching the data to the system to get each person's tweet. The data set will be containing tweets from different persons, and in each tweet we will analyze in preparing step, analyze and initialize the data and the tweet using natural language processing methods and tools. We will use NLP tools to remove useless data and use the configured data in the system. After preparing data, we will ask the vendor to give a keyword. The keyword will be used for making the recommendation. The vendor will provide the keyword to find tweets that contain those words or something similar to them. After finding the similar tweets in the similarity process, the similar tweets are found and recorded in a special variable. When searching for the keyword and selecting tweet, similarities are listed, and those similar tweets are used for recommendation. For each tweet, the user who wrote that tweet are listed, and then users are recommended as a list to be targeted by the vendor. The vendor in this case can easily target the person who may like his service or his item that he wants to sell it. As a data preparation step, in this process, tweets are analyzed and needed meanings are extracted from the tweets. Natural language process follows a set of fixed steps and uses some tools and algorithms that help filtering text. Remove appendix from it and prepare it for processing. First, we use annotation and tokenization. After that, we use named entity recognition, NER, and then analyzing and then removing URLs, HTML tags, emojis, and symbols. By using these steps, the data will be prepared to enter into models, algorithm, and method. The algorithms that we used or the methods that we used in our system were first the TF-IDF. We use TF-IDF as a statistical measurement for evaluating the relevance of the word to the tweet. After that, we used cosine similarity for measuring the similarity of two tweets vector. And then after that, we used content-based filtering as a recommendation approach, which used for recommending the tweet after calculating the similarity. Now, with the TF-IDF, the TF refers to the term frequency. Term frequency is calculated by how many times does the word came in a document divided by the total number of words in the same document. The other term, the IDF, is mean inverse document frequency, IDF, and it is calculated by taking the logarithm of the number of the document in the frame divided by the number of document where the specific word appears. Using the both terms in our system, and depending on the equations that get their value, if the word is very common in this document and appeared in several documents, the value of the TF-IDF will be close to 0. Otherwise, it will be close to 1. The higher the product of the two value, it means that the word is relevant to the document. We use the term TF-IDF in our process as a preparing step to prepare the tweet to make recommendation. And we can say that we used the TF-IDF in the first as the first method to complete the process. After that, we have the cosine similarity. Cosine similarity is determines whether two vectors are pointing in the same general direction by measuring the cosine of the angle between them. As we can see, and for text analysis, it's frequently used to determine document similarity. In our case, we are using it for considering the tweets similarity. With the cosine similarity, we made a function that measures the similarity among the tweets of the dataset. The function takes the tweet ID and converts the tweet to vector. After converting the tweet to vector, the function will find the similar ones and save the result in other dictionary. The dictionary will be resulted of pair of similar tweet and the ID. In our process, we use the ID to find the similar tweet. The vendor, after that, will insert the ID and configure how many tweets does he want to be recommended, and we will see that in result section. The content-based filtering. Content-based filtering is one important approach of recommendation system approach. Content-based filtering in the case of recommending usernames to a specific vendor is based on the comparison of the tweets and matching with other tweets. The content-based filtering recommends only users that their tweets are highly similar to the ones containing the keyword of the vendor. Based on the specific function of our process method, the higher similar tweets are recommended and in the number which will be determined in the processed function. We use dataset that contains 500 tweets about the hashtag just do it. We got the dataset from kaggle.com. All tweets happened on 7 September 2018, which is the day after Nike made a no announcement to Andros Keeping, who was a famous player. In the dataset, there was 500 tweets. From that 500 tweets, we used 80% as a training set and 20% as a test set for training and testing the data. The dataset contained ID and tweet full text, which used as a tweet. Then it was containing tweet ID and tweet retweeted count. Also, it contained user created at, which means when does this user create his profile. It also contained user default values with true and false. This column was made to determine if that user is real user or boot user. This column could be also determined for extracting real tweets and real persons. The description of user and the favorite count and followers count and thread friends count also was in the columns of the dataset. The user ID, which was used in case of similarity detection. Also the user location. If we want to provide a list of users according to a location, we can use this column. And username also, and user profile name. These values also used in our process system to determine as a specific criteria with the vendor's keyword. Finally, the use of our method helped the community provider or the vendor to find suitable customer and also facilitate access to the customer. Considering the use of the system based on data taken from Twitter, the results showed the destination of the system compared to the rest of the data analysis system. The basic idea of the system shows how important it is to use the text filter before start processing. In the method and as the result, our system succeeded to recommend the target customer list with 86.24% accuracy. We used accuracy metric for measuring our system's accuracy, and the following function will be recommend function in our system. The item ID will be determined by the vendor. Also, the number of persons which we want to recommend also will be determined. And based on the similarity, the users were recommended for the vendor. Thank you very much for your attention.
Thank you for presentation. Is there any question? Okay, no question. Anyone not presenting? Okay. All presentation completed in this session. Is there any question about Congress? Okay. See you in other session.